welcome. Yes, my name is Nastya, and I'm head of digital at Gart Solutions, and I'll be like a moderator for today. And we're here to talk about why compliance is not a growth blocker, but actually one of the strongest growth levers for health tech startups, and not only health tech startups, actually. Especially that one that aim to enter the US market, EU markets, and so on. And with me today, two experts, yes. First, Roman. He's our cloud architect and CTO and co-founder, who's designed HIPAA-compliant architectures for real health tech, healthcare platforms. And second, Feder is our CEO, co-founder of Gart Solutions, and also cloud architect with experience in healthcare digital transformation. So the webinar will last about 45 minutes, and we will have Q&A in the end. So feel free to drop questions in the chat at any time. I will read them later. And let's begin. And maybe, Feder, you can share the agenda for today.
Yes, thanks, Nastya. Hello, everyone. Today, Roman and I will go through 5K blocks essential for any of health tech startup. First of all, we will talk about, let's say, the illusion of a fast launch. Why the idea of launching first and fixing compliance later almost always leads to expensive failure. Then probably Roman will explain how complaint infrastructure is built. We will talk about three layers like network segregation, encryption, and zero trust access. After that, I will cover compliance automation inside CI/CD pipelines and compliance as a code. We will talk also about AI-ready data foundations, why healthcare AI fails due to broken data pipelines, but not because of algorithm. And finally, zero trust architecture, zero trust healthcare AI architecture, including the real case study. Will show you how it actually works in a real world. So let's start with what is probably the most important topic for today's session. I call it fast launch trap. You've probably seen this more than once. A startup build a prototype in just a few weeks using some low-code platform like Lovable or something else. PHI protected health information ends up scattered across an encrypted database and S3 buckets. There is no network isolation. Development and production environment are running inside the same flat VPC, and there is no audit trail whatsoever. And at that point, the founders are feeling great, yeah. So they're thinking we're moving fast, we make a progress, so everything goes well. And to be fair, they are. But then comes their first enterprise opportunity in the US or in the Europe. The hospital's legal team or insurance company security team starts a vendor overview. They begin asking questions about HIPAA compliance, data segregation, encryption, access control, audit logging, and multiple other questions. Yeah, and suddenly everything comes to halt. The deal is paused, the security review failed, and the team realized that they cannot just patch a few things and move on. The architecture has to be redesigned from ground up. Let's try to look into some real numbers. If you build compliant into your product from day one, that is your baseline cost. Let's call it 1x. But if you decide to deal with it later, you're looking at costs that are probably 3 to 10 times higher. Yeah, so it's not like a 3 to 10% higher. It's actually 3 to 10 times. And that is not only cost. Uh, when architectural gaps are uncovered during a legal security review, enterprise deal can get delayed by anywhere from 6 to 18 months. For startups which are limited runway, that kind of a delay can be devastating. Here is another number worth paying attention to. Uh, HIPAA violations can result in penalties for up to 1.5 million per category. That is based on OCR enforcement data from recent year. And one last reality check. Every hospital CIO, without exception, will conduct a security review before signing a contract with the vendor. There are no shortcuts around that process. So, here is the key takeaway. Compliance is not actually a blocker. It only becomes a blocker when you treat it as something you will figure out later. If you build it into your architecture from the start, compliance stop being a hurdle and become a competitive advantage. Yeah, so probably we can move to some VPC isolation. Yeah.
Yeah, thanks, Fedor. Hi, everyone. So now we are moving more to the practical part, and I'm going to show what compliant infrastructure actually looks like from the side of technical perspective, from the inside. Usually we split it in 3 layers, like a network segmentation, data encryption, and zero trust access. So during the next couple of slides, we will go through each of them. Okay, so the first layer is network isolation, and I usually put a lot of attention to this layer because for any infrastructure, this is a base ground, and it's very something that is very difficult to change later. And because if you go to a physical data center of your host in the cloud, every service that you create, it's like tightly coupled with a network, and you could not change it later without redeploying your service. So it's not a easy change. So there is a part where like a lot of planning required. And the key principle is simple. Any service that handles PHI runs in a private subnet with no direct access, and only public entry points are strictly controlled by API gateways, firewalls, web application protections, etc. If you need communication between multiple networks, for example, analytics and clinical environments, you stop this peering or VPN connection. And again, so firewall as a central point, no default connectivity. Each service layer, web application or database, it should have own security group over network control, principle of least privilege. So it's a ground rules. Database only accept allowed connections from the trusted applications, not from the internet for sure, not from the developer subnet, not from the I don't know, anyone's laptop, whatever. And for sure, like no public IPs on the processing nodes and database, Kafka, Elastic Cache, whatever. So everything should be in private by default, and it's a good manners not only for regulated environment like healthcare, but it's a good manners for every infrastructure. But if you're talking about some sensitive environments, some regulated environments. It should be paid more attention here. Next slide, please. Yeah. So the second layer is encryption, and we usually think about it into two parts, data at rest and data in transit. For data at rest, everything is encrypted with AS256 by default. And for example, all database services or data in buckets and storage accounts, and we enforce policies that allow stored unencrypted data. Also, for data in transit, everything should be run on the latest version of TLS security protocol. Older version, the newest one is 1.3. Old versions like 1.0 and 1.1 are completely disabled. Certificates are managed and rotated, like short-lived certificates are preferable over a long-lived and automatically rotated with a Let's Encrypt or some ACM. Not build them manually for sure. Between the services inside the application or microservices inside the application. So we prefer to have a multiple TLS for trust to each other. And engineers who are accessing to private infrastructures, they should go through the approved technologies like VPN or some zero trust technologies. So we'll talk about them next slide. So what about zero trust? So it's this third layer, and the principle sounds simple, never trust and always verify. It's a shift that we are seeing for a couple of last years with the growth of software as a service, software SaaS products and cloud technologies. So we could not protect only infrastructure anymore because physically protect, because previously when users went to offices, they were able to work only from the office, from their desk, and this desk was protected because laptop connected to the office network, and you could not without access to without physical access to the laptop, you could not do anything within the system. But right now, reality is different. More people are working from home or in a hybrid mode. So we are protecting not only infrastructure, we are protecting also user accounts and user workspace. So if talking about zero trust access, so what principles are here? Okay, least privileges. We completely move away from static API keys, some path tokens stored in a somewhere in text documents, whatever, and use more IAM roles with minimum permissions when we actually need it. Credentials are rotated automatically, no secrets stored in Git, everything is scanned and so on. For sure, MFA for everyone, configuring that user is a real user, and we could confirm the identity. MFA for some high privilege detections when we want to rotate some secret or access some database, for example. Yeah, the MFA should be enforced. Between microservices or services inside your application, we already talked about this. So MTLS should be enforced. So services should know how to should know each other and communicate securely through the secure channel established at TPS using mutual TLS. And finally, continuous success verification. So it's not just we verified an account or user once during login time and do not verify it next 90 days. No, so yeah, we're checking on every request, checking with some security tool set if it is potentially like harmful operation and we need to verify user additionally. Yeah, so when you have this, you could be also audit ready. Yeah. Okay. And yeah, basically, it's not something new. Um, but if you're talking about this this measurements that we are doing for being more secure and compliant from the beginning, for sure, infrastructure as a code also is part of this process. So we do not focus on the Terraform. Terraform here is just an example, but talking about this, automated it from the beginning because automation of your infrastructure will give you some proof of how it's built. And you also could prove later that you are not doing manual changes in your infrastructure. Every change is like validated, approved, potentially it could be rolled back to the previous version. Every security group, every address change or key rotation, it's stored in a Git, and Git will be your source of truth for any kind of questions. Yeah, so that's important. And for sure, for sure, you could also implement additionally on top of infrastructure as you call it, separate layer, but you could implement infrastructure policies in your cloud environment whenever Microsoft or AWS or Google, they all support policies for setting up what is allowed and what is not, setting up your boundaries for the infrastructure.
Okay, thanks, Roman. Now let's talk a little bit how to build all this stuff into actually automation tools and CI/CD processes. The idea is simple. Compliance checks shouldn't happen after deployment. They should happen at the commit stage. Fail fast, fix cheap. Catching issue earlier is literally order of magnitude cheaper than fixing them in production. Here is what our pipeline looks like usually. After every code commit, several stages run automatically. First of all, we try always run SATs and SCA scanning. It's pretty important stuff. So, static application security testing finds vulnerability directly in the code. While software composition analysis checks, it will check all dependencies for known CVEs. Second is a compliance check. Tools like Checkoff validates Terraform configuration against HIPAA and GDPR controls, and OPA policies ensure we are not violating any internal rules. Third stage, we run a container scan using some tools like Trivy. Every Docker image is scanned for vulnerabilities before it ever reaches the registry. And finally, the deploy gate. If the code fails any of these checks, it simply doesn't reach production automatically with no human intervention. The result is a continuous audit readiness. You are always prepared for an audit with a zero manual preparation required. We integrate it with different CI/CD tools like GitLab CI, GitHub, or Jenkins, or whatever, depending on what the client already used. The tools are standard and the learning curve is actually minimal. So here I want to start with a slightly provocative statement. Everyone says that data is the new oil, but in a healthcare, data is not actually in oil. It's more looks like shale. There is a lot of it. It's highly fragmented and it's extremely expensive to process. And there is a key point. AI models in a healthcare don't fail because the algorithms are bad. They failed usually because the data pipelines are broken. And we are going to show you two real and quite well-known example of just to prove that. Next slide, please. Yeah. Let me tell you two quick stories about healthcare AI gone wrong. The first is sepsis model, a tool built to catch sepsis early. But when researchers tested it on a real patient, it scored like 0.63 or something. For comparison, flipping a coin scores 0.5. So it was barely better than guessing, yeah, and it was already running in a dozen of hospitals. So what went wrong? The patient is trained on didn't match the patient it was used on. No one tracked where the data came from. So when things shift, it went unused. And no one was monitoring it in a production. So as it got worse, nobody noticed. Your data from the moment it's collected all the way to the model. You set up automatic alerts for when real-world data starts drifting from the training data, and you review performance for each patient group on a regular schedule. The second story comes from Obermeyer and his colleagues. They studied a popular algorithm that decided which patient got extra care and found it was quietly overlooking black patients. Even when those patients were sicker, it was less likely to flag them for help. Why? One shortcut. Instead of measuring how sick someone was, the algorithm used how much money had been spent to their care. But spending doesn't measure need, it measures access. And historically, less was spent on a black patient, not because they were healthier, yeah, but because they had less access to care. The algorithm learned that inequally and repeated it. Uh, and one more checked for it before launch. The fix again lives in an infrastructure. You run fairness audit before anything shipped, broken down by group, so you can actually see who the model is failing. You review the features you're feeding it and pull the ones standing in for something they shouldn't. And you keep watching for a bias when it's live. So here is what I want to take away. In a healthcare AI, a good model isn't just about algorithm. It depends just as much on the quality of the data infrastructure around it. Yes, so let's probably move on. Let's talk about healthcare data shouldn't move to be
Yeah,
used.
it's our final architecture block, and I have a couple of words here to say. So what I want to share here is a principle that I believe it's quite fundamental for any not only healthcare but AI products that live in regulator environment. And so data. So the principle is data doesn't need to move to be used. Yeah? So the traditional approach how a lot of companies are doing, so they're collecting data. So there's this approach is quite natural. That's why it's really risky. So you collect data for your data provider or potentially, I don't know, some personal devices, some fitness devices. You collect this data, moves them to the cloud, centralize them, then like process and train your models, deploy, doing something with them. And the problem is that this operation immediately runs into all the set of compliance and regulations that we can have, like HIPAA, GDPR, NIS2, European Union AI Act, whatever. Yeah, so at the same time. And in reality, uh, no hospital in the European Union will sign like DPAA for transferring raw patient records. Yeah, no one will allow this. No one will accept this. So if you want to do this, it's totally makes sense to think about this and follow the other principles. So the first one is localized analytics. It means that basically try not to move data, try keep them where you don't need to regulate or to implement additional things on this. So try to use, if you're using AI, like try to run it into your data producer environment, or just aggregate and minimize output of the data set, and then like before it's leaving the network. Yeah, so try not to move the raw records if it's possible. The second one is EHDS aligned services or microservices. It's more about your product architecture. So if you have a service architecture, microservice architecture, so design it by default to comply with European health data space. It means that you need to enable like secure API for cross-border research without transferring the raw patient data itself. And the third is be compliant by construction, implement all the principles that we have told earlier from the beginning, like enforce zero trust, enforce least privileges policy, attribute-based access control, immutable audit logs, like all of this in a complex give you like or simplify like a legal review cycles for your company.
Okay, so now let's move to some real world case interrelated to one of our real client. Yeah. What was the challenge? The challenge is an AI neuro imaging platform that needs to integrate with the multiple hospital networks to analyze MRIs and X-rays. We are talking peak clinical workloads and strict rule, no raw patient images can ever leave a hospital network, uh, not under any conditions. So what was the solution? The solution came down from key components. First of all, it's a HIPAA-aligned VPC design. Each hospital runs in its own isolated VPC with dedicated private subnets for imaging workloads. We used VPC peering with strict security group rules, so any across hospital data flow only happen when it's explicitly allowed. The next one is a zero trust integration layer. And MTLS authorized API gateway connectors to hospital systems. Every PICS system gets its own unique client certificate, and if needed, access can be revoked per certificate. So without no downtime, no disruption, so everything is clear. Uh, the next one is in network AI interface. The interface engine runs directly inside the hospital network. Only structured outputs like analysis report leave the environment. No raw MRI data ever does. It's like a GDPR and HIPAA compliant by design. And the last one, it's a peak load architecture. Uh, we use auto-scaling GPU clusters with SRE monitored SLOs. The system elastically absorbs sudden spikes in radiology demand, so performance stays stable even during the biggest hospital workloads. And that is really the point. Brian.K shows that compliant and production grade scalable aren't like opposites. When it's done right, they are the same thing. Okay, let's move forward and do some kind of wrap thing up with a practical playbook. It's something you can actually use if you're building or scaling your health tech products right now. Yeah. Uh, Step one, it's a 360 IT audit. Before you build anything new or start some refactoring, you need a clear baseline. Where are you today? Where is PHI exposed? Where are the security gaps? Where is the production readiness issue? And ideally, you do this before you code ever touched in a hospital environment. Step two, it's architecture replatforming. Move away from ad hoc prototype infrastructure and toward like a HIPAA and GDPR aligned VPCs, private subnets, proper encryption layers, and strict access control. This is exactly what Roman works through in like our second part. Uh, Next step is automated CI/CD gates. Build security validated pipelines. It's a quite important thing. No code goes to production without passing compliance checks, vulnerability scans, and container security scanning. Uh, this is what we covered in the third section. And step four, it's an elastic scale for a medical environment. Try to use auto-scaling groups, read replicas, and SRE monitored SLOs. Hospitals don't tolerate downtime. They need systems that stay stable even under the peak clinic load. Uh, Yeah. So, and finally, five key takeaways from today webinar. Yeah. So what I want to say first, it's the fast launch trap is real. Um Retrofitting compliance later costs 3 to 10x more than it can delay enterprise deals by 6 to 18 months. It's something you want to design from the day one. Second, compliant infrastructure has three core layers: network segmentation, data encryption, and zero trust access. Third one, compliance as a code is a force multiplier. Tools like Checkov, Trivy can always be in your CI/CD pipelines. It means every commit is automatically validated against hundreds of controls. Fourth, AI models usually fail because of broken data pipelines, but not bad algorithm. Data proneness, bias audit, and production monitoring matter before you even train the first model. And the last one, in the European Union market, GDPR needs to the EU AI Act and EHDS aren't an optional. Zero trust architecture where data never leaves the hospital are the compliance pattern, yeah, and it's like obligatory, and it's can satisfy all of them at once. Uh, yeah, so that's it probably.
Yeah, that's it. Thank you, Fedor. Thank you, Roman, for today's session. And I just wanna pause for a second, and I need to tell the world who we are. Yeah, really. Gart Solution is your digital transformation partner, and we don't just talk about compliance in a theory. Our clients actually, after working with us, deploy more frequently. Yes, they recover from incidents faster and have lower change failure rates. So these all are DORA metrics, the industry standard for measuring engineering performance. And we are proud of these numbers because it's real outcome of our clients. And so if after today's session, after today's webinar, you are thinking, okay, but how does it apply to my specific situation? Just drop us a message because we are open for communication and available for discovery calls. Yeah, so it's all for today. I don't see a question in the chat. If you have additional question after the watching the webinar in record, you can drop us a message. And thank you for being with us and have a nice day. Goodbye, guys.
Thank you.
Thanks,
Thank you.
everyone.
Bye.
Cheers.
Bye.